should do something. Okay, I'm gonna put it on SG2 on space now, and then we can get started. So,
Okie dokie.
so you can actually see this at youtube.com/C, like the letter C as in cat, /Shen, SHEN, last name GE, so Shenge, /live. So it's youtube.com/C/Shenge/live. And if you go there, you will see, well, you will see me. So, just let you know. Okay.
Lovely.
Yeah, last time I gave you a really long URL, but apparently when you do live, you have like this short link that you could just share. So that's all good.
I'm just on my phone right now. So I'm out walking in the neighborhood trying to get away from noisy people.
Noisy people?
Yeah, since the COVID thing, people are out working on their lawns. There's jackhammers and nails going on, and everybody's trying to do stuff.
Yeah, I noticed. People don't want to sit inside all the time. It makes sense.
Yeah.
And it's not like you can go to the movie theater or a restaurant, so you just end up being outside for the most part, from what I see.
That is cool.
Okay, it is. All right, so okay, you can mute yourself for a little bit. All right, everybody, this is Shenge. Sorry for the slight delay. You are clearly, if you're watching, SG2 on space. Now, this is episode number, wow, I said episode number 64. Wow, let's be able to talk here. Okay, so hopefully you're watching on YouTube or Facebook. I would actually suggest YouTube since Facebook is going a little funky, but hey, assuming you're watching, you have the source down wherever you're watching. All right. So this is what, 5th or 6th week since we all had to stay home. So for better or worse, what this is meaning is that I'm still not in the studio, so don't quite have the tech of the studio, and you can hear the background noise because, well, people just like to make, I don't know, some motorcycle. All right. So, in any case, this is episode 64. Once again, follow me, facebook.com/The Shen Show. Be sure to also subscribe to my channel. My channel is youtube.com/cast725, or you can just look up SG2 on space. I'm sure you will see a bunch of videos, at least 64 of them, since, well, clearly, well, episode 64. All right, so what was I going to say today? Well, today, once again, we are having Dr. Leonard Kramer on. So if you guys have been listening in the past, you know he has a very strong physics and aerospace background, currently works at Boeing, and is a frequent guest on the show. For all I know, I might put him as co-host partly, so considering that we've been doing this a lot. So today we are going to actually talk about the moon. Now, not to go into too many technical details, we're mostly going to talk about, the historical aspects. So, Leonard, can you hear me?
Yeah, I can hear you really good. Can you hear me?
Yeah, I mean, yeah, your voice is always quite resounding. Yeah. Okay. Well, Leonard. So the moon.
Yeah.
What's going on with it? Why do we? What? I mean, we say the history of the moon. Let's start with that. Where does it come from?
Well, there's a history of the moon that's sort of interesting. I guess everybody knows what the moon is. The solar system, many of the planets all over the solar system have moons. Objects that are orbiting around them. Galileo observed moon around Jupiter and Saturn, and kind of clued him into, the solar. That's like a little solar system. That's like planets going around the sun, and so anyway, it was a big revolutionary observations there. The origin of the Earth's moon is a little bit mysterious. There's a lot of things that aren't really coming together scientifically over the years, and we've learned a lot since Apollo about the composition of the moon. Turns out that its composition is very similar to the Earth. There's two things that are looked at. The ratio of oxygen isotopes and I think titanium. There's something having to do with titanium isotopes that are regarded by scientists, people that know these things, as signatures of just the Earth, and that every planet is different in that regard. So we know with almost certainty that the Earth and the Moon are very, very closely related. They came from the same material. This wasn't known in the 19th century, but beginning in the mid 19th century, a descendant of Charles Darwin, as it happens, made some theories about the origin of the moon, and posited that, well, the Earth in ancient times, in the primordial past, was rotating very quickly, and it somehow ejected a piece of itself. Earth ejected a piece of itself, and the scar of that is the Pacific Ocean. So he just was looking at that. That turns out not to be right. It was an interesting observation. I remember being little and thinking that. Thinking about that. Maybe I read about that theory, but I remember thinking that. Later on, people were looking at these kind of ideas and positing that there's some kind of impact.
Right.
So that's the current idea, that when the Earth was forming,
there's a Mars-sized object called Theia, Theia, which apparently possibly hit the proto-Earth. Gigantic impact, and then from out of there, the moon and Earth formed. Well, Earth was already there, but the moon formed.
That seems to work pretty good as a theory. Somebody came up with a name for it. Of course, we never observed it. We don't know precisely anything about that specific event.
So, yeah, go on.
That helps explain a lot of things. Some of heard about the idea that, well, there was an orbiting body that came close and that somehow the Earth captured it. And that turns out not to be even remotely possible.
Why is that?
Well, because when objects are in and just randomly floating around, and then the gravitational forces, well, the energy, the amount of kinetic energy will increase at the expense of the potential energy of the interaction. And so two bodies that are approaching each other, unless they collide, unless they physically collide, they will not, they will, one body will speed up, the other one will speed up, and then they'll just sort of dance around each other, and then they'll return to the
original orbits. I see.
So there's no physics really that allows a orbiting body to be captured by another one unless there's some loss of energy. So there really has to be a collision, and that's why people are favoring this impact. So probably in the early proto-solar system, there were two bodies that were in close orbit, closely aligned orbit that had condensed out of the primordial gas. And one was moving slightly faster. The smaller one, the Mars-sized one, was moving slightly faster or slower. And the two bodies just collided together. And it merged the mantles of the two bodies. And the moon fell into an orbit. It recondensed, and it does help to explain a lot of what we observe. So the isotopic composition of the crust is virtually identical.
Right.
It's almost incontrovertible that the Earth and the Moon come from, or the surfaces of the Earth and the Moon come from the same materials. Also, the Moon is much less dense. It doesn't have an iron core, apparently.
Why is that?
Well, the idea is that the Earth was a larger body and had time to condense the iron and nickel and heavy elements would fall to the center, and this smaller body then collided with it without disturbing the core. So
apparently I'm reading this, and it does have a very small iron core. And I know it was geologically active in the past with volcanoes and things. So I mean, I'm not saying you're completely wrong, but I am saying that it does have some iron inside. Yeah.
Also doesn't. It's also not. It's the mass distribution inside the moon is not symmetric. It's not spherically symmetric. It's fairly. It has what we call. It has large non-spherical quadrupole moments in the gravity field. So one thing about that, for Apollo, when they were modeling the gravity of the moon, they had to use three bodies.
Why is that?
Well, spherical harmonics, which is the normal way that you would model the gravity field, didn't work very well. It tended to converge very slowly. You needed a lot of term, but somebody figured out let's use like three bodies that are connected as solids together, and use that as the gravity model. It's also why the moon is so subject to tidal locking with the Earth. What's tidal locking? Means that the same face of the moon faces the Earth all the time, and that's because gravity, what they call gravity gradient stabilized. So on one side, so the moon has these internal asymmetries in the gravity field because there must be like big things embedded inside, big objects that are embedded inside, or big massive, and they're not symmetric. And so one side is getting pulled more than the other side, and it tends to stabilize in the degree that the Earth's gravity on the moon changes with distance. So it's sort of like wiggles around until it finds a stable direction, and that happens to be with one face always facing the Earth as it rotates around. A lot of bodies in the solar system are like that. It's very interesting. It's a very interesting thing. But was I clear about that? Does that make any sense what I said?
Yeah, it makes sense to me, but I think you explained it quite well. So yeah, let's just from please continue. You were going to say something else? Musings are a good thing. So let me ask you this. I mean, since ancient times, the moon has always been in the sky, and people have obviously noticed it, ranging from, writers, poets, artists, religious folks, whatever, astronomers, obviously, and I would say it had a pretty large impact on the development of our whole society up to a point. I mean, including our calendar system, for a lot of traditional calendars. And religions as well, mythologies. So now,
but that's me. Other people have other Greek goddesses or gods that they're
well, every ancient and even modern civilization, I don't know about monotheistic ones, but polytheistic ones at least had a goddess for the moon, pretty much. Uh, which is reasonable because the sun was a god, right, or goddess, and so come on, there's a moon. Those are the two larger celestial bodies observable from the Earth, relatively speaking. So I guess my question here is from a science perspective. I mean, we like before Galileo observed the moon's surface. What did people think was what was it like? What was it made of? That
I don't know how anyone would know what thought about it. I think in medieval times, people thought that it was some kind of otherworldly, outside the universe kind of place. It was not even really a material thing. It was some kind of heavenly thing, on a different plane of existence.
right.
Maybe you can find. I don't want to say where I read this. Maybe you can find Thomas Aquinas or the ancients writing about the moon.
Yeah.
But
I mean, it is quite remarkable that some of the ancient astronomers were able to, without telescopes, actually estimate somehow the size of the moon. Some of them realized that the moon actually creates the tides, like what is it, Celestius of Okay, I cannot say this Greek name. Whatever. Um, and then others have postulated or estimated like the distance from the moon to the Earth and all that, which is really and the fact that it's spherical, and that it reflects the sun's rays. So, I mean, clearly we knew, at least some of the astronomers knew quite a bit from the technology they had. Um, Sorry, is that a dog? Okay.
there was a dog that was harassing me just now.
Yeah. Let's. Yeah. Sorry. You okay?
Yeah, I'm okay. I'm out. Like I said, I'm out walking. It's a little bit unusual.
It's all good. If I could do this outside walking, I'd do it too, but I can't. Um, so you mentioned Galileo to start with. What did Galileo reveal that was not known before? No, I'm not kidding. Explain it.
That he got from a Montgomery Ward catalog. No, I'm kidding about that.
Wow. Okay. Wonderful.
He found out about some new technology that was being
Mm-hmm.
And put this telescope thing together. I think other people had telescopes, and I expected to look at the moon too. But he was a professor and then very respected, and was able to express and articulate more about that than anyone before him. So when he looked at the moon, he saw the surface. You know, he saw mountains, and he could see the sun glinting off of craters as the moon turned. So he was the first person really in history who saw the moon as a place that was like the Earth. You know, and you have to contemplate that a little bit. That's so wild, because in all of the human history before, people looked at the moon, they didn't know what they were looking at. They just saw like some smudges.
Yeah. He wrote a book called Sidereus Nuncius, and actually it means starry messenger, but I assume that it contains a lot of the observations of the fact that the moon's not a perfect sphere, but actually has craters and mountains, and he drew them. So he was the first one to draw actually features on the moon, which is pretty cool. So now, that to me was a little surprising, but with your naked eye, Leonard, can't you see some of the features? You can't?
I remember when I was a child, I was a fairly precocious child.
I can't imagine.
I was able to see a lot better, and I was able to discern some things, but I don't ever recall being able to make out anything on the moon as a child.
Huh.
With my 13-year-old eyes, even though I was looking, but I had access to telescopes and microscopes and all kinds of things as a child, but I don't remember being able to today. Are you able to make out any?
No. I mean, I honestly, yeah, you're right. I see shadows typically, but I can't tell if those are actual features unless I look zoom in through a camera or a telescope or binoculars. So yeah, that makes sense now why the ancients, or rather before this, what is it, early 17th century, before Galileo, people didn't really think too much about the fact that it actually has imperfections, let's say. So
I was looking at it last night. Actually, it looked. I think it's a new moon last night. And in the new moon, when you're looking at it, there's obviously a little crescent of the moon, and I'm sure a lot of folks have observed that in the dark area of a new moon, you can actually see some light. You can see something.
Yeah.
Have you observed that?
Yeah. What is that?
You don't know what that is?
Yeah, tell me what that is.
Okay, well, from the vantage of the moon, under those circumstances, when the moon is just a crescent, the Earth is full. It's almost completely full, and so there's this bright moon. I mean, there's a bright Earth observable from the moon in those circumstances, and the light from the moon, from the Earth, and keep in mind it's about 5 times larger, 5 times bigger diameter, with a huge thing in the sky that you would be seeing. It's illuminating that dark area, and a little fraction of that light is being reflected back to Earth. So it's the Earth shine on the dark side of the moon that's then reflecting back to the Earth, and it makes the dark side of the moon, but that's not the dark side, but the in shadow part of the moon visible.
So you're saying that the reason we can see a bit of the moon even when it's the new moon is because light is reflected from the Earth, like sunlight is reflected from the Earth, and it hits the moon. Wow, that's kind of interesting.
Yeah.
Huh.
And some people I have encountered some people I've talked to about this, and they, in their minds, they conflate that with, like, the lights from civilization, like the electric light or something like that. That's not it at all, right? I had somebody tell me one time, and that will increase as more and more lights appear on the Earth, but it's not human caused light. It's just the light of the sun shining on the Earth, and then reflected to the moon, and then some very tiny little fraction of that reflects back to the Earth.
Yeah, that makes sense. Just letting you know, I'm looking at moongiant.com/phase, and yesterday was apparently not the new moon. April 23rd was. Yesterday, April 24th, was waxing crescent, 2%. And today, it is waxing crescent illumination, 5%. So,
Earth shine
yeah.
on the darkened side of the moon, and it's still the case that that same side of the moon is always facing the Earth as the moon orbits around the moon orbits around the Earth.
Right. That's pretty cool. That you know, pointing this out. So considering we're talking about all the stuff, do you have a favorite feature on the moon that you like to look at or talk about?
No, I like all of them.
So there's a big difference between the near side and the far side. Why is that in terms of, I've heard like the geological features?
What I heard is that the dark side has some very large impacts that had broken through to the mantle. And so there's a lot of interest in going back there and recovering some pieces of the mantle of the moon. So it's sort of an accident, but it's probably really not an accident because it probably changed the internal distribution, meaning some kind of external impact that was always very large that changed the internal distribution of masses inside of the moon, and also ripped open the lunar crust at that point. So that's why. I mean, there's a large.
Right, I see. So you're saying it's due to the impactor that somehow the side that's there's two very distinctive parts of the moon. So like the far side has a lot more craters, uh, while the side we see is very smooth in like many of the regions, relatively speaking. Yeah.
I would say I don't know if it has. I'm not going to dispute that it has more craters, but that's not the most significant thing. The most significant thing is that there is a very, very large area that appears to be disrupted by an impact that is distinct from the primordial impact that created the planet first. So, and scientists are interested in that area because they'd like to get at some part of the mantle. You got to go down something like 40 or 50 kilometers before you get to the mantle.
So, yeah, go on.
Yeah, and so it's thought that some elements of the mantle are exposed on the dark side.
Right.
On the far side.
Are we the dark side? Yeah, far side.
Dark. It goes through the face just like the visible side.
It's just the far side since we can't see it, or dark side, I should say. From here on Earth. So, dude, are you planning to go there someday, Leonard?
No.
I see.
I'm afraid of the cosmic ray flow.
Okay, so actually, let me ask you this: what are some of the challenges if we're ever going to win? Actually, we decide to settle there.
Well, I think that the moon is really in the interplanetary environment, far from the Earth. There's no magnetic field shielding it from the radiation that's in the environment. And humans can't really live in space, even inside of a capsule, for more than, I don't know, a year or so, because the radiation, the cosmic rays, then the occasional high energy solar flare event pose too great a radiation, biological, cause damage to the human body or any body. So that's the main challenge, is that needs to be shielded, and it's not at all easy or obvious.
So let me ask you this: when the Apollo astronauts went to the moon, they seemed to be fine. How was that possible?
They were only there for 3 days.
Okay. Huh.
They were in the environment for weeks. They were only in the interplanetary environment for a week. I don't think it's possible for humans, unshielded, and I don't mean exposed to the vacuum, but I mean inside of just a plain aluminum capsule, to live for more than a year or so without becoming
right. So let me ask you this: I actually had a heated discussion with some friends of mine back in last August. There was some college reunion, and somehow the conversation drifted to, hey, like, why are we spending money going to the moon? So let me ask you this: why are we interested from your perspective?
Well, I'm really not the right person to defend it from that point of view. I would just say that it's not expensive.
Okay.
It's really not expensive. I mean, the whole NASA budget is less than $20 billion per year, and our economy, the U.S. economy, is, well, it used to be before certain virus started decimating us, was on the order of $20 trillion.
Right, that's a drop in the bucket.
So
wow.
20,000 times bigger. 20. Yeah, 20. So it's not. It's a few dollars per U.S. citizen.
No, that makes perfect sense. Are there resources on the moon we can exploit? Not exploit, like mine. Is there something that that will be advantageous that way?
That's a really interesting question. With a lot of things to talk about.
I mean, I know that we recently discovered that there's more water and ice on the moon than expected.
There seems to be water in the polar areas in the form of ice.
Right.
Ice in craters.
Yeah.
That are never exposed to sunlight in the polar region of the moon, and those would be valuable for establishing some kind of base there.
Right.
I mean, the shielding issues can be overcome, the radiation shielding. And that can be done going underground, of course.
Yeah, of course. There's a number of ways.
I presume that the crust of the moon has as much resources as any place on Earth.
Yeah, since you said it's similar.
So, but one thing that is there that you'll read about is this thing called helium-4, or is it helium-3?
I think it's helium-3. Yeah, people talk about that for like fusion reactors, but we don't have fusion reactors, so.
We don't know how to use helium-3 in a fusion reaction. We haven't even achieved fusion as a control source. But these are alpha particles that have been deposited. Alpha particles from the solar wind. under rocks surface, and so it's thought that there's large amounts of this material that is not present on Earth, and that if we were ever able to achieve nuclear fusion,
well, like we do have nuclear fusion, it just produces less energy than we put into it, which is not helpful. Yeah.
It's not clear to me that, I don't know, I'm not an authority on that, but it's not clear to me that we've actually been able to use helium-3 in a fusion reaction, but I could be wrong about it, other than just an atomic accelerator experiments.
Right. And I know helium-3 comes about because, well, I think you just said it, it's from the solar wind. On Earth, since we have an atmosphere that stops most of those charged particles, which, I mean, glad we have an atmosphere. I'm not saying that, but we should. That's very interesting stuff. Hey, so let's step back from science a bit. You read science fiction. Do you have a favorite when it comes to the moon?
When I was little, I loved Isaac Asimov.
Right.
I'm sure I've read everything that Asimov wrote. Who was the author of 2001? I don't know why I can't ever remember.
Isn't that Arthur C. Clarke?
Arthur Clarke wrote some stories that I read as a child about the moon. There was one that was called Islands in the Sky.
Islands in the Sky?
I think that was about a young kid that gets recruited to be an astronaut and goes to the moon.
Okay, let me see. Apparently, this is one 35 juvenile novels that make up the Winston science fiction series. Blah, blah, blah. The typical protagonist in these stories was a boy in his late teens who was proficient in the art of electronics, a hobby that was easily available to the readers. Okay, so this is about Roy Malcolm. He's an expert in aviation, its history, and technology. Blah, blah, blah. Yeah, you're right. Wait, hold on a second. I think he goes to Mars. Yeah. Oh, Mercury, too. Well, they do stop by the moon they swing around the moon, refuel the ship from a container catapulted to them from the crater Hipparchus. That's interesting. Wow, that's I haven't heard of that one. Well, I mean, it's
Author of the Time Machine and H.G. Wells.
what?
He wrote From the Earth to the Moon, and that's quite good.
From the Earth to the Moon.
And that's more along my steampunk genre.
That's actually that's Jules Verne.
From the Earth to the Moon is Jules Verne, right?
Which is way back when. That's interesting. I mean, Jules Verne is known for a bunch of sci-fi stories that was actually fitting reality to a point.
About going to the moon. Like First Men in the Moon.
Oh yeah, First Men in the Moon is a scientific romance by English author H.G. Wells. Blah blah blah. The novel tells the story of a journey to the moon undertaken by two protagonists, a businessman narrator, Mr. Bedford, and an eccentric scientist, Mr. Cavor. Bedford and Cavor discover that the moon is inhabited by a sophisticated extraterrestrial civilization of insect-like creatures they call Selenites. Well, that sounds very interesting. Wow. Okay. You read that one?
Yeah, I read that one. There's also a movie. Now was able to go to the moon in 1890. But I don't think that's in Wells's novel. They added that, and it's pretty endearing.
Interesting. Are you still taking a walk, Leonard?
Yeah.
Okay. All right. So,
I'm not exactly sure where I am. I'm going to walk. All right.
Yeah. I think you're on the moon now.
Yeah. Well, there are suburban neighborhoods on the moon.
There are. Interesting. So, actually, this actually gives me a good question. So, most of us are probably not going to go to the moon or have that opportunity, even if we want to. So, where on Earth, on this planet, can we go to see like things that are possibly similar to what we would observe on the moon? Are there like volcanic islands somewhere?
South America, in Chile and the Andean region, that have similar kind of geography that can be used to look at or to examine the kinds of terrain that one might see there.
Mm-hmm.
Earth is so heavily resurfaced with tectonic movements and resurfacing, recycling of the crust of the Earth that there really isn't anything. There's very few places where there's primordial crust left on the Earth. So there's nothing like that I'm aware of. Certainly, I've been in places that are very rugged, like way out in West Texas, where you can enjoy rugged terrain.
Right. Yeah, no doubt. Okay, I was just curious. So, well, it looks like a storm is brewing around here. I think we came to a good time to stop, Leonard. Any other last comments?
Stay safe and stay hygienic.
Yeah, social distancing. What? Go wear a astronaut suit. Pretend you're on the moon. No, don't do that. Although that will probably protect you from germs for sure. All right.
Yeah.
So, okay, with that, thank you, Leonard. You've been listening to SG2 on Space. Follow me, facebook.com/The Shen Show. Follow me on YouTube as well. Look up SG2 on Space. And I will say still, whenever we get back to the studio, I will say follow Action One Media. All right. Hopefully, be back in about a week or two, whenever this is lifted. So, what is our catchphrase?
Keep looking up for something.
That works. I haven't talked about UFOs in the sky lately, so whatever. But you can look at the moon. Look up because you never know what you will see.
Yeah, especially tonight because you'll see the dark side illuminated.
Indeed. All right. Thank you, Leonard. Thank you, everybody, for listening, and we will see you next week.
Bye-bye.
Bye-bye.